Welcome to this video. Okay, so in this video I'm going to show you guys how to solve trig equations. And however, the examples I'm going to show you guys here, normally when we're finding trig equations, we're solving trig equations, we need to find the angle. And questions like this, they will give us certain limitations on the angle that we have found. Okay, so let's take a look here. Cosine of x is equal to root 2 over 2, and they want us to find x, which means find the angle that will give find an angle that has a cosine value of root 2 over 2. However, your angle of x has to be within negative pi radian and pi radian. Okay, it has to be within negative pi radian and pi radian. So we have many angles that will give us a cosine value of root 2 over 2. But they are only interested in the ones within this range, negative pi to pi. Okay, but first of all, let's see where it is at. So cosine of x is equal to root 2 over 2. And we know that the cosine is the x coordinate, right? And the y coordinate is the sine of the angle. So if it's positive root 2 over 2, it's going to be somewhere here. So the angle could be here, or the angle could be there, because both of this angle, this is my angle, say theta 1, and I'm gonna have another angle that will be there. Sorry, that will be here. Okay, this is my theta 2. Okay, so both of those angles, cosine of theta 1. It's going to give me root 2 over 2, and cosine of theta 2 is also going to give me root 2 over 2. The y values might be different, their respective sine values might be different, but the cosine values would be the same. Okay, so if you don't understand what I've drawn here or what I have talked about here, please go back and watch the previous videos. Yeah. All right, now let's continue. And in fact, this root 2 over 2, it is actually the cosine value of some angle. It's going to give me root 2 over 2. I hope you guys have remembered the trig ratios, the trig values of the special angles. The angle here, my theta 1, is actually going to be pi over 4. And my theta 2 is actually going to be, that will be 7 pi over 4. Right? Okay, so if you're not sure how I got these angles, please take out your unit circle, and you should find these angles there. Now, so it seems like I have found my x already, because right now my x is either theta 1 or theta 2, correct? And I have just found them. Theta 1 is this, theta 2 is that. So everything looks good. However, we're not exactly done yet, because it says that my angle has to be within that range. It has to be from negative pi to pi. So all we have to do now is to turn. What do I mean by turning? We just have to turn either in the positive angle direction or the negative direction, so that we get the angles that fits within this negative pi and pi range. So let's start with the pi over 4. First, you analyze the pi over 4. Is pi over 4 within the range? Is this, so I have negative 1 pi and all the way up to, I have negative 1 pi all the way up to positive pi. I'm going to remove the 1, yeah? So this is negative pi all the way up to pi. My pi, and between that I'm going to have a 0. Right? 0 is going to be somewhere there. Pi over 4 is going to be where? It's going to be somewhere here. Right? Pi over 4 is going to be somewhere here. This is going to be my pi over 4. So which means that is, my theta 1 is one of the answers. That's for sure, because it fits. Cosine of pi over 4 gives me a root 2 over 2, and also it is within the range that is given here. It satisfies the range. Okay. Now let's take a look at the 7 power over 4 here. Now 7 power over 4. Again, if you kind of make a line that a number line. 7 power over 4. 7 power over 4 is equal to 4 power over 4 plus 3 power over 4, correct? And 4 power over 4 is equal to pi plus 3 power over 4, which means if I want to put this on the number line, my 7 power over 4 is going to be somewhere here, right? Because we are going to have, this is say 0. I'm going to go pi, and then I'm going to go extra 3 power over 4, which means this is outside the boundary. This is outside the boundary. Okay, the 7 power over 4 is outside the boundary. We can only stay within this range. Within this part, right? But right now 7 power over 4 is here. So too bad we can't use 7 power over 4. However, now we can just turn. This is when we are gonna start turning. So we mentioned about this in the class. We can always turn, but when we're turning, we have to be careful with which direction we are turning. Right now, my angle is too big. My angle is way too big, right? So what I'm going to do is I'm going to turn in the negative direction so that it brings the value down. And I'm going to turn a full circle. I'm going to turn a full circle, which means I'm going to have 7 power over 4. If I turn in the negative direction and then I'm turning a full circle, I'll have to minus 2 pi. Right? Clockwise direction, that gives me a negative. And then I'm turning a full circle, that's 2 pi. And if I change it to fractions, which will be easier to see, 8 power over 4. So my final answer will be negative power over 4. Now, negative power over 4, so this angle here, this is 7 power over 4, and it is also negative power over 4, right? It's both different angles, but we're at the same spot. We're at the same spot. So negative power over 4, let's put that on the number line. Negative power over 4 is going to be somewhere here, yeah? Because this much is negative pi, and I'm only going a quarter of that much. So negative power over 4 is there, which means negative power over 4 is also a good, would also be a solution, right? So instead of using 7 power over 4, I will actually rotate that by 2 pi, negative 2 pi, sorry, and I will get negative power over 4, and that would be my answer. So my x could be power over 4 or negative power over 4. Okay? So there's definitely you guys must be familiar with the trig values of some special angles, and then after that we just have to know how to turn in a way that's gonna satisfy the boundary given to us. Okay. A challenging part would be to figure out whether this 7 power over 4 is it within the negative pi to pi boundary. So if you kind of create a number line, that should help you to see if it's inside or outside the boundary. So break it down. Like see what I did here. Break it down into smaller fractions where you can see a pi, and that's kind of my maximum value for my x. And then we see that I need to go this extra bit of 3 power over 4. So definitely that angle is outside of the boundary, and because it's way too big, that's why I'm gonna minus a 2 pi. Right? I'm gonna minus a 2 pi to bring it down, and hopefully I get an angle that satisfies the boundary. Okay. In the next video, I'll show you guys another example, but feel free to rewind and take notes. Yeah? See ya.